Hey there, Prof. Aram here, and in this video I'm going to go over different types of loans and loan amortization. So let's get to this. So the first type of loan is a pure discount loan, in which, it's the simplest type of loan where the borrower receives the money today and they have to pay one single lump sum in the future. For example, US Treasuries is a good example of this type of loan, pure discount loans. Sometimes we call them zero coupon loans as well, or zero coupon bonds. An example of that is the US Treasury. US Treasury bills are sold at a discount, and the principal is paid at some point in the future without any periodic or interim cash flows or interest payments. So if a T-bill promises to pay $10,000 in 12 months, you receive the future value of $10,000 in 12 months, right? So let's say a year. It doesn't say anything regarding the compounding, so I'm assuming that the compounding is annual. So N would be 1 year, and then IY, or the discount rate, would be 7%. You can calculate the present value today by simply discounting the $10,000, 1.07 raised to the power of 1, which is 9,345.79. So in other words, you obviously, because the promised cash flow is $10,000, you are going to pay an amount lower than that. That's why we call them discount loans or pure discount loans. Or, in the calculator, you could just use N of 1, future value 10,000, IY is 7, and then solve for present value. The other type of loan is an interest-only loan. In this type of loan, the borrower pays only the interest every month or every year of the life of the loan, and then the borrower has to come up with a balloon payment or a lump sum for the principal amount of the loan at the last date, at the maturity of this loan. For example, consider a 5-year interest-only loan with 7% interest rate and the principal amount of $10,000, interest paid annually. So the stream of cash flows is like you're going to pay $700 interest on the loan every year from year 1 to 4. And then in the last year, on top of the last interest that you have to pay, you have to also come up with $10,000, the principal that you borrowed in the beginning. So this was kind of troublesome both for banks and borrowers, because let's say you borrow $100,000 to buy a house, and after 15 years of making simple interest payments, you have to come up with $100,000 balloon payment to repay the loan. So it was really hard for individuals to come up with that money, and that's why banks came up with another idea, and that's the amortized loan. So in an amortized loan, you're going to make fixed payments every period. So in this case, for example, consider a 4-year loan with annual payments. The interest is 8% and the principal is $5,000. So you're going to make 4 payments of $1,509. But this payment is going to have 2 components. Part of that is the interest on the loan, and part of that goes towards principal. Meaning that as your loan ages and as you make payments, you're also paying off the loan. You're also paying off the principal. So with the last payment, you owe $0 to the bank. So let's look at an example here. In the Excel sheet, so you start with $5,000 and you're going to make 4 equal payments each year. In this case, the amount of interest would be, how much was it? 8% of the principal each year, or 8% of the balance of the loan each year. So 8% of 5,000 is 400. So out of this $1,509.60 that you make, that payment that you make in the first year, $400 of it goes towards interest, and the remainder, which is $1,509.60 minus 400, goes towards the repayment of the loan, goes towards the principal. That means the ending balance of the loan at the end of the first year is going to be $3,890.40. So this will carry over the beginning of the next year. Now your interest is going to be 8% of the balance. So because of that, as you pay off the loan, as you pay off the principal on the loan, the interest that you pay on the loan goes down and down and down. So out of each payment, the portion of the interest will go down and the portion of the principal will increase as the loan ages. So the good thing about this type of loan is that when you make your last payment, you owe nothing to the bank. The balance would be zero, right? So how do we do this in the financial calculator? The first thing you do is always calculate the payment. We always need a payment first. So second, future value, we are borrowing 5,000 at 8% for 4 years. We compute the payment. After we find the payment, 1,509, you need to go to this function, amortization function. So second PV will take you to the amortization function. P1 is the start of the period. If you go down, P2 is the end of the period. So if you want to look at the first year and decide how much interest you're paying in the first year, how much principal you're paying in the first year, and what is the balance at the end of the first year, you keep P1 and P2 both at 1. Okay, so we go down. This would be the balance at the end of the first year. This is how much principal you pay in the first year. And this is how much interest you pay in the first year. So if you want to find out what happens in the second year, so we change this to 2 and P2 also to 2. This is how much is the balance at the end of the second year, how much principal you pay, and how much interest you pay. Let's say you want to know how much interest you pay over the life of the loan. So we set the starting point as 1, and P2 would be the ending point, which is going to be 4. So the balance, of course, at the end of the 4 years would be 0. And you pay the principal 5,000. And this is the total amount of interest you pay from period 1 to period 4. Let's look at another example of this amortization table. Let me close this. Here, you're looking at an amortized loan of $250,000. The term of the loan is 15 years, but because you're making monthly payments, you have 180 months. The annual percentage rate is 10%, but because, again, you're monthly compounding, your monthly rate would be this. So the balance of the loan would be the $250,000 that you have here. The payment would be the rate, number of periods, and then present value. Interest would be your monthly rate times the beginning balance. Here is 250,000. It makes the principal the difference between the payment and interest. So the beginning balance on the loan in year 2 would be the $250,000 original amount minus the principal that you paid in the first month, right? But the key point here is that your payment doesn't change. Another good thing about the amortization, amortized loan, is that you know exactly how much you need to pay every month, so you can plan for it. So this planning aspect of it is also very interesting and desirable for a lot of investors, for a lot of borrowers. So if you do this for 180 months, you see that the total principal that you pay on this loan is going to be, of course, 250,000 original amount that you borrowed, and $233,000 in interest is paid. Of course, the balance of the loan would be zero at the end of the life of the loan. So here you see that I graphed it. As the loan ages, as you can see, the height of each column is 2,686.51. The payment of the loan is fixed over the life of the loan. The monthly payment is going to be 2,686.51. But the proportion of that payment that goes towards principal and interest changes over the life of the loan. So earlier in the life of the loan, a big chunk of the payment goes towards interest, and a small part of it goes towards repayment of the loan, the principal. But as the loan ages, you see that the principal amount is going to be larger compared to the interest. So that the key point here is that if you don't want to pay a lot of interest on your loan and you want to pay extra on your payments, you better do it earlier in the life of the loan than later, because in the later payments, only a small part of it goes towards interest. But earlier in the life of the loan, a big part of the payment goes towards interest. So if you want to repay the loan faster, you better do it here, right? You better make more payments in the beginning of the life of the loan rather than later. I hope you find this video useful, and thank you for watching.